Hi, welcome everybody. I'm going to be speaking today about View architecture and Compose and how both things work together at Twitter. But first things first, my name is Nacho and I'm a software engineer at Twitter, and I've been here for almost 5 years now, and I currently work in a team called Android Core UI. That's my Twitter handle if you want to follow me for whatever shit posting or whatever you want. Uh, so let's start first talking about how your architecture looks like at Twitter. So a long time ago, not so long, in 2017, we didn't have any prescribed UI architecture. Every team would use the one that they prefer. So some teams would be using MVP at the time. Some teams back then would use MVC, for example, or camera stack is done with MVC, and some other things. Well, it's a 13-year-old lab, so you can imagine there is all sorts of legacy stuff from the ancient days was present back then. So, but this was a very bad idea. So by this I mean letting every team choose their own architecture, and it was a bad idea for a number of reasons. Mainly because onboarding to other parts of the code base was rather difficult. So we started with a wish list of what we wanted to accomplish in UI architecture. So the first thing that we wanted is a solution that allowed and forced us to follow good engineering principles. We also wanted a solution that was adopted by other teams, so onboarding to new parts of the code base would be easy. We wanted to be able to use it to create reusable UI components in an easy way. And architecture components were launched around the same time in 2017, but unlike the architecture components, we wanted our components to be fully injectable, so we control how they are instantiated, so we can manage them completely by DI. We wanted to use our own lifecycle dependencies, etc. So Android X or Android architecture components was kind of out of the question for us. So this was our first proposal, and you would be right thinking it really looks like MVVM. It was MVVM based, but the kicker here is that we added a layer in the middle that we were using for two-way data binding. So we would provide this two-way data binding via this specific binder class, where the view model and view delegate would exchange subscriptions that would ultimately be disposed by the framework automatically. But we tested it and it was still too unopinionated. We're going to see why. So, as a feature developer, you had to write three big classes. So you will have to write a view model for the business logic. You will have to write a view delegate, which was like our view part of MVVM. And you will have to write manually this view binder, which was in charge of the data binding. And that felt like too much. This view binder we were talking about is just glue code. It's very mechanic to write, and they are very different from one another, so that we cannot really generate them. Also, it was kind of error prone, so some people would be adding kind of bleeding business logic from their view models to their view binders, etc. And it also required Java expertise, and that proved to be too cumbersome for most people that were not very comfortable managing their streams. You typically have like a bunch of people that are very comfortable using Java or Reactive streams, writing, all of that. But most people just want to get on with their lives and get their job done, and it was kind of a blocker. So how did we fix that? Well, we went back to the drawing board and we said, okay, if we know how inputs and outputs look like in both sides, the view model and the view delegate, then we are able to generalize the binder. So from the MVVM skeleton we had before, we take a simple view model and look closely. we can see how it would expose a series of output methods with the observable streams and a series of inputs. In here, you can see them as like these methods that we can call. Same with the view delegate, we will have a bunch of methods to update the UI components and a bunch of outputs with reactive streams to react to user interactions. Then the binder would act as the subscription glue for all of them. But the thing is, this part needed to be implemented every time, and it can get long and it can get boring, and it's just glue. It's nothing exciting. It's nothing that you have to really think thoroughly or anything whatsoever. So as I said, it's glue, so we want to get rid of it. So if we merge all the streams into one, we kind of create a stronger contract in the view model interface. So if we provide one input and one output in the view model, and we do the same thing in the view delegate, so then the view binder will always be the same. So we will always subscribe to a state observable, and we will always call render in the view delegate with whatever that outputs, and the same thing with the subscribe to user intent observable in the view delegate, and then call the process user intent in the view model. So by doing that, this part is now generic, and this means that we don't have to implement it at all. It's reusable. So we will only need to implement the view model for business logic and the view delegate for UI, which seems fair. It's the two parts that you would want to write for the future. You don't want to write the glue, but you want to write how the business logic works and how the view is rendered. So this means we move from MVVM to MVI, and that is what we are currently doing. We have an internal framework that we call Weaver that does this two-way data binding step, and it also provides you with a simple API for using MVI. So Weaver is the amalgam of all of our UI architecture, like all the tiny frameworks that comprise our UI architecture. We can start looking into what parts conform this framework. The first one is data binding. So we add to the layout XML a tag with an arbitrary string. In this case, it's just my component there. Then when we are inflating the layout, after we inflate the layout, we start a view traversal and we go through the view hierarchy. And then we will eventually get to the view that has this my component tag. And based on that tag, we would be able to look at the definitions in the eye for the current view layout and grab from there the view model, the view binder, the delegate, and then perform the binding. And this will happen for all the views in the hierarchy, so there might be multiple components that can be bound in this way. MVI can be quite boilerplatey, so what we aim to do in Weaver is to remove or reduce those rituals. Like, for example, you normally see intents that get translated into actions that then get processed, and then from those results you reduce them, and then you output a view state. Weaver specializes in state management via using MVI with an API that's simple to reason about. And this is because we want to hide away all the RX stream complexity so that users don't need to care about it at all. We're going to see some examples of how this API looks like. So first we got set state. This is something that you would see in the likes of React. You would see this in Mavericks and many other frameworks. It's a way of translating the state that we had before into a new state. So basically inside of the Lambda, you write your reducer. And then we get useState, which basically means that we grab the most up-to-date state. Because everything is asynchronous here, it's not as simple as using a getter. Then we get this yield effect because we found out that it was very useful for us to have a separate stream that's not refire upon resubscription. So all of the side effects that we want, like launching a new activity, like putting a fragment over there, whatever, uh, kind of scribing, so analytics, logging, etc. Like we can do that with this, and it won't be done again upon resubscription. Then we added a DSL so that you can interact with reactive streams inside of your repositories in an easy way, and we can work and play a little bit with the results, maybe adding a loading state, making so that the failures don't fail the whole stream, react upon failures, react after a success or a failure, or on complete, which is very useful for completables, maybes, and all those sorts of streams. And then we have a shortcut that's called that's for the specific case where we only care about success. We don't care about loading, we don't want loading, we don't want to care about failure. Also, the core of this MBI that we use at Weaver ensures that the view model is responsible for generating the information for the view delegate to render, and the view delegate relays the user interactions to the view model. So, if the user is doing something in the UI, the view model would be notified. Then something will happen in the repository, maybe or not. It could happen. Maybe we are querying the network for some up-to-date information. Maybe we are just hitting the database, whatever. Then all of those get moved into a new state, view state, that then gets sent to the view delegate, and the user can see that. So we see that the data flow originates from the user, and the user creates the inputs, and the user would receive ultimately the outputs, but there is no middle communication in there. Components are automatically initialized when data binding happens. So the aim for us is to create activities that are empty, and that their components are self-managed, they are standalone. So if our entry points are defined in this XML tag that we will then inflate and then we will then process, we can grab the instances from the UI, and they would be attached to the UI in the proper scope and initialized on their own. So in the DI we will find the view model, the delegate, and the binder, as we saw before. As I mentioned, the view model is a scope to survive configuration changes, and the view delegate and the binder are bound to the actual activity or view. So view binder and view delegate would be recreated upon a configuration change, while the view model would persist. Everything is asynchronous by default, but we provide some scheduler, some very sane defaults with ways of overriding. So the threading model on Weaver, it gets simplified by quite a lot. A subscription for the whole component and the subscriptions to the streams that we are using in the view model via repositories, etc., are managed automatically, which means that if the view model gets destroyed, those subscriptions will be cleaned up automatically. Testing business logic is because we are using MBI, it's black box testing. So you provide some inputs and you know that you want to get some outputs, so you can assert to them. So it's very like you don't care how it's implemented on the inside, but you want how you want it to look like. So it's very powerful just by default, but we also provide a testing framework that helps creating given, when, then style of tests based on these view models. And then we also have a IDE plugin, so an Android Studio plugin that's automatically distributed to all of our developers, which allows us to create new components, navigate from XML to the code, to any arbitrary code, navigate from the view model to its compatible view delegate, etc. And we also support time travel and basically seeing all of the state changes and how they came to be, and also replaying some states or setting an arbitrary state directly into the state machines of our view models. So this is what the framework that we call Weaver is doing for us. But the question is, does it work well with Compose? And well, we are going to see about that. After Compose was announced, it made us think about how your architecture framework would work alongside it. Luckily, the way of working that we are pushing for and that Weaver is based on is the same that Compose encourages you to use. To be fair, we're taking into account compatibility with other declarative frameworks like Litho when we were designing Weaver. So it was easy. The data binding part was also not necessary, so Compose is going to be the one doing that for us now. So we don't need a view delegate, we don't need a binder, and we can substitute what they did by just pure composables. Also, we needed to make sure that it worked the same independently of which Compose adoption strategy people were inclined to follow. So we needed to provide the same composition locals for infrastructure setup and provide like these interoperability layers with our own infra. So the API is that simple. We can grab arbitrary view models and we can subscribe to state changes on them. We can subscribe to changes in specific parts of the state. Maybe we want just a field, like the contents of a field, so we can do that. We can do this on more than one parameter, up to any number we want. And we also have a way of managing the side effects in a Compose compatible way. So basically the insides of this lambda wouldn't be a composable, and they would be like the subscriptions with that side effects stream would be automatically disposed when the composable would be recomposed. So let's see in action. Let's say that we have a user interacting with a follow button. We can use a stateful composable to access the source of truth of the data, in this case whether the user is being followed or not, and this lies in the view model. We will also have a stateless composable to render that code on the screen. We initially render the current state, whether the user is being followed or not, and we get that info from the view model. So when the user taps on that follow button, the view model gets wind of it because we notify it when the button is pressed. The business logic does its bit, and a new following value gets created because of that. Then the UI gets refreshed with a new following state, and the user sees that what they did worked. It was similar to how you would interact with Android X view models in Compose. It's the same principle: stateful composable with a stateless composable, and a stateful one interacts with a view model. So now that we know that our bet in your architecture framework and Compose work well together, we know that we can adopt Compose. And how did this adoption came to be? Because our case is it's quite difficult to make these things happen, because we have a massive app which is 13 years old. We have more than 100 individual contributors at the moment, so 100 developers shipping code every day just on Android. So we can't just go and throw everything away. We need a strategy to follow here. So let's see what we did. So first we created a test app to be able to use Compose, Weaver, and the rest of the Twitter infrastructure together, like our database layer, network layer, etc. We wanted to ensure that the normal feature would be usable if done 100% in Compose. Then we started adding Compose to the build to make sure that the new IR backend wouldn't break anything else. We invested in a Gradle plugin to easily enable Compose in a module, so adding Compose to a build.gradle file for a particular module is just one line of code. We also started creating Compose versions of our design system components and our theme. We aim to provide the basic building blocks a developer might need when using Compose in their feature app Twitter. And as you're likely not going to find all the bugs in isolation, the core UI team, so the team I'm part of, partnered with select feature teams that they wanted to use Compose and they wanted to early adopt it. They helped us find the worst bugs and told us which API they found clunky so we could fix them, and we did. We also had to document everything for them to be able to use Compose effectively in our application. So education is king. So we took a big gamble and wrote a lot of documentation. We created a lot of internal talks that we were then giving over time in our meetings with all hands of the contributors on Android. We created code labs. We created a Slack channel for Compose. And all of this was done even before opening Compose usage for everybody. So people would start to get hyped up, and they would start to investigate, and they would maybe on Hack Weeks they would use some Compose, etc. Then it was time for to open usage for everybody. So we want collaboration to happen in the open so that we can creating experts that will help others in their path to Compose. So we have to foster this so that any question that people have about how to do something in Compose or what's the best strategy, we kind of prompt people to share in a public channel so other feature developers can also contribute to that. And the idea here is that some people will rise up and become experts. And after Compose's usage is open for everybody, updating the Compose dependencies should be owned by a particular team. In our case, it's the core UI team. For this to work well, we require robust testing to make sure that updates don't break things. So we need integration testing, we need instrumentation testing, etc. Kotlin and Compose versions are also likely going to go hand in hand, so we need to have good collaboration with the team that manages Kotlin updates, so the platform team that manages these updates and our team need to work closely together. It's like sometimes Compose forces you to update Kotlin and sometimes Kotlin forces you to update Compose if we want to use like the latest and shiniest one. Let's put our focus now in how to adopt Compose. Given that Twitter is massive and a long-lived code base, how did we focus on specific adoption? At least not talking about philosophically, but actual migrations. What problems did we encounter? So well, we found out that screens that were already migrated to Weaver were the easiest to port. Because only the UI layer needed to be rewritten and the rest was reusable wholesale. So we could basically reuse all of the business logic. So screens containing Weaver were also the newer screens, so the ones that were done in past few years. We can also add to this group trivial screens that are sorting the legacy side, because we can migrate them easily as we go and leave the code in a better state than it was. So for these cases, we can migrate our UI with a top-down approach. This is also what we wanted to validate with our early access program that I was talking about before. So working alongside feature teams doing greenfield features is a really good proving grounds for this top-down approach. And for this migration strategy, we would rewrite the UI using composables, starting from the top. So in this screen, for example, we can focus on rewriting a topic timeline. It could look like this. All the state would be managed by the same view model that we already had for the view-based implementation. And this simplifies things by a lot, but we only need to care about the UI layer and not the business logic. So the business logic is mostly reused. The UI part is then straightforward to implement. So based on the state, we create a bunch of stateless components to render on screen the information that we need. And as we start going down the rabbit hole of creating these composables, we will likely find components that haven't been migrated yet and there is not a composable for them. And do so might be a huge undertaking. So for these particular examples, like in this case the face file, we find that if we find that the component is too complex, we can always delay its migration, because we can wrap arbitrary views with the Android view composable and just keep going. So this way, we can always properly migrate this later on, and we have time to properly evaluate that particular component API, whether we want to do a one-to-one migration, whether we want to improve something, or maybe go a different direction with it. However, in the case of more modern screens, or more complex screens, or screens that haven't been modernized yet, we can use another migration strategy, which is the bottom-up migration. We are battle testing this via our design system component updates, and we will see how. Let's see with an example. So profile activity is one of our legacy activities, and we can single out some of those components in it and only migrate them to Compose. In this case, this button row of elements. So originally these items, these views were Twitter button instances, which is our view-based button. It's based on app compat button. We can take these Twitter button instances and we can swap them by a new implementation. So Compose provides us with a class called Abstract Compose View that allows us to run composables inside of a custom view. So we can then write all of the code to provide a compatible behavior with Twitter button, and then delegate their values to the composable that renders the actual button. And of course, we also need to provide compatible styles with the original XML styles if we are doing this. So we provided mappings for the old styles to the new Compose and Kotlin-based styles. So you can see here that if we have a style for it's like Twitter button, large bold, like we would, in this Horizon Compose button, we would use the Kotlin class that defines the style for it. That's going to be used in Compose. So we are trading off using XML to instead using the way better writing styles in code approach. So doing a couple of these migrations by hand is okay, but what if we have thousands of them? And what if we want to do some A/B testing? So for this, XML won't help, because XML, like, well, we cannot code in XML. You will have to do this programmatically, right? So for that, we have this. We use this component called AppCompat View Inflator to automatically switch views. And you will be saying, "Wow, what is this?" So basically, you can, in your theme, you can provide this view inflator class value, which would be a fully qualified name of a class. And this class should extend AppCompat View Inflator. And in this class, you will have a method called createView, and then inside of it, you will have the information of the views that are going to be created upon inflation. So in this case, if we see that the Twitter button is the one that we want to create, we can choose whether we want to actually create a Twitter button or we want to create a Horizon Compose button. But also, what if we want to be more selective? What if we want to target these migrations? What if we only want to move a handful of them automatically and be able to test their A/B test their performance and behavior? Well, instead of using Twitter button, we can create a subclass that's empty, that's called migration Twitter button. That would be kind of a throwaway, so we don't need to keep it around very much till we productionize this code. But it allows us to kind of allow list some classes for migration. So this way, only those components that we added to this allow list would be swappable for the Compose backed view. So if you want to be selective, use a different subclass only in the elements that you intend to migrate. This allowed us to be very fine-grained in the views that we wanted to A/B test with. So now that we have seen how automatically switch views in a way that would work well for pure XML usages, but what about programmatic usages? For those, we can specify a common interface. We could use this interface in both the old and view-based components and the new compose-based component. As we can see, both the new compose-based button and the legacy button have a common ancestor now. Because if we look at the normal state of things, we can see that view.java is the most common ancestor for both versions of the button, the legacy and the new compose-based one. So we need to insert something in the middle to be able to provide a cohesive API between the old and new implementations, especially for these programmatic usages. So the idea is that this interface would be thrown away when the changes are productionized. And we aim to make that deletion process simple as well. So we wrote this interface in Kotlin at first, but there were a bunch of issues with Vue.java functionality and Kotlin property access syntax. So as I said, it's throwaway code, so use whatever makes your life easier. So for programmatic usages, we suggest that you create a common interface between the old Vue-based component and the new Compose-based component. We also found problems with maintaining state with these custom views based on existing Vue-based components. Let's see that with an example. So let's say we want to manage the state of this text value in our composable. It can either be set via XML or be changed programmatically via a set text method. If the view gets recreated because of configuration change, process death, we're not guaranteed that text is going to be the last text we had before. So we have a couple of options. We can either use a view model like a Weaver one or Android X one to preserve the state, provided that the VM can persist the data properly, and we can use it as a source of truth. For this, we would also need to route the programmatic updates so that they are reflected also in the view model, but it's definitely doable. But there is an alternative provided by Compose. So Compose gives us a composable called Remember Savable, which facilitates state preservation. There exists a problem with this, where the configuration change causes the mutable state defined in the abstract compose view to mismatch with the remember mutable state in the composable. And to work around this, we simply put in a side effect to the remember savable call after the remember savable call to ensure that the view field is updated to reference the current mutable state instance that we relay on in our composable. Or you can use the view.java on save instance state or restore instance state manually, because it's a view, so you can still do that. So you need to think about preserving state when abstract compose view is recreated. So these were some of the adventures we had when working with Compose in our rather big app. In reality, as we are using a Vue architecture that is a great fit for Compose, doing these migrations is simple enough. Our investment in Weaver has proved really valuable now, as we can hit the ground running with 100% Compose-friendly business logic. But it doesn't matter which framework you use, whether it's vanilla Android X view model, Mavericks, Mobius, Weaver, etc. Investing in Vue architecture beforehand paid off. So we're getting close to the end. It's a good time to wrap up and recollect everything that we were talking about. We saw how Vue architecture looks like at Twitter. What was the journey from no architectural guidance whatsoever to the current opinionated MVI approach. We learned that the Weaver framework, what it does for us at Twitter, it simplifies the UI-centric development and allows for reusability. We finally saw how Weaver alongside Compose can be used to create modern UIs, and what strategy we follow for Compose adoption, both from the organizational perspective and the actual nitty-gritty of coding, and some problems we had to fix along the way. So no questions because this is a recording, but thank you very much.